we're looking at designing concurrency, building some scalable data platform solutions. We're going to be looking at what we used to traditionally do, how we used to achieve scalability with the database engine, and then we'll start looking around some of the new design patterns and the new principles and some of the new ways we can design highly scalable data platform solutions using the different options that are available to us. We don't have to do everything in the relational database engine anymore. So, that's what we're looking at. If that's not what you're here for, feel free to find another session. I won't be offended. Just set some expectations. My laptop blue screen, so I put it on the table, so see how it goes, but probably not going to be any demos because it's feeling a little bit delicate at the moment. I've actually lost the ability to shut the laptop down through the start menu. So we'll see. A little bit of admin. Big thank you to all the sponsors. Okay, without them, the events like this can't happen. So please go speak to them. There's some great sponsors up there. So have a chat. I know the guys at Prophecy quite well. I can vouch for their solution being very good. A little bit about me. My name's John Martin. I'm a product manager for a company called Century1. We do monitoring solutions. Don't let the word manager scare you off. I am still technical. Prior to joining Century1, I worked for Microsoft as a field engineer with SQL team based out of the UK. Been working with SQL Server in one form or another for the last decade or so. Contact details are there. So please feel free to take those down, picture, write them down. I'm going to make sure the slide deck goes to the organisers, so I guess they'll send them out, things like that. Otherwise, I'll pop them up on SlideShare. It's not a problem. I've got business cards there if anyone wants to get in touch. Data Platform MVP. That's me. Worked with SQL Server in one form or another for ages. So, without further ado, we'll move on. So, when we start thinking about concurrency, one of the key things we need to understand and the key elements we need to take into consideration when we start thinking about concurrency and what's going to impact the system is the different type of workload that we're going to be facing. Okay. Now, can I have a show of hands in the room? Who here is developer or developer focused? This warms my heart. DBA? Okay. Due diligence, I used to be a DBA, but I'm a firm believer that the DBA shouldn't be doing too much. The developers own the design and everything like that, so it's nice to have a room full of developers. Now, when it comes to workloads, we think about OLTP workloads, transactional workloads. These are typically the ones where we're looking for high concurrency. Okay, so this is where we're looking to really sort of deal with and mitigate locking, blocking, and things like that can get in the way of us writing data into a system. Would everybody agree with that, or predominantly read workloads? What are the thoughts? I'm going to ask you guys questions, so just sat in the wrong place if you don't want to give me answers. But yeah, I mean, in my experience, data ingestion is typically the major bottleneck when it comes to concurrency, especially when you're dealing with systems like sensor systems. If you've got e-retail systems, for example, where you've got a very scalable, load-balanced front end, that can just, off it goes. Load balancers, web servers, auto-scale systems, that's great. But your single point of contention is going to always come back to being the data store, typically, in our traditional database and traditional data platform models. So that's where we've needed to deal with the problem before, historically. That's the transactional workloads. If we're dealing with big reporting workloads, you'd think large numbers of reads, not a problem. Reads coexist really well with each other. Depends. There's the DBA side. It really does depend on the size of those queries, the size of the data sets they're working with, because that will have an impact on the size of the memory grants and things like that that are being given to the queries. So rather than being locking and blocking, which is our primary focus when we're dealing with transactional ingestion-based systems, when we start looking at read-based systems, where there can be big concurrency issues as well, how big are those queries? How much resource do I have available for memory grants? If I've got large parallel queries, okay, well, how many schedulers do I have available to me on which I can actually process these reads? those are big issues as well. So it shifts from actually being a contention at the allocation level to actually system resource issues that are going to start limiting your contention. Okay? Or sorry, creating contention and limiting the way that you can coexist these queries. A great example is the Azure SQL Data Warehouse system. Now, in SQL Server, we've got a certain amount of memory, we've got a certain amount of CPU. We can ask it queries that will give us certain results. And if we've got more memory granted, or if we're granting more memory than we've actually got, then we're going to start waiting. Okay? Azure SQL Data Warehouse is actually limited to 32 concurrent connections in its biggest form. So if you want to put that behind a dashboard, again, that's going to give you some issues around how many queries you can run concurrently, even if they're really small. In the scale of something like Data Warehouse, you've got 32. So you've got a dashboard with 8 different things on it. That's 8 different connections, and you've got 10 people looking at it. 80 and 32 doesn't go. Okay, so again, we start thinking about areas, and this is where we need to start thinking about the system. System thinking is very, very important. Okay. Now, what we want is the best performance we can get. Okay. Now, optimizing the database to within an inch of its life, great. But if you don't find and strike that balance at the system level, you can tune the components really, really well individually. But when you tune one, that can have an adverse impact on another. Okay? So you need to think about the relationships and the interactions between the different layers. Okay? With me so far? Yeah. Nodding heads, this is good. No one's running off screen. So this is where we need to really start. We need to think about the types of workload. Okay, now when we look at what we've traditionally been doing in the relational engine, okay, is again we're going to ask for a show of hands here. Who is dealing still primarily with the relational SQL engine in one form or another, be it Azure SQL Database or on-premises SQL servers? Okay, half the room, which means a lot of people now. Document DB, JSON document format type thing? No? Okay. Can anyone tell me, anyone didn't put the hand up about SQL Server, either A, you don't want to put your hand up, or B, you're using something else, in which case, can someone give me an indication about what you're using? Analysis services. Okay, that's an interesting one. That's a completely different beast, analysis services, when it comes to that side of things. My experience with analysis services is very little contention in the engine layer. It's about storage. We're not specifically going to cover analysis services, but if we find time at the end, got any questions, we can go down that way. So, when we start thinking about the options that we have, like I say, we've got to start taking that system mindset when we start thinking about all of the different components. Okay. Now, traditionally, we've had our main data stores. Okay, these are relational database engines initially. SQL Server, Azure SQL Database, SQLDW. I'm also going to put Azure sort of document DB. Well, what was document DB until they called it Cosmos and made it planet scale. Whatever that is, we'll find out, I guess. But our data stores are one of the tiers of our system. Okay. Then we can look at moving up to an intermediate layer. The intermediate layer, as I term it, is this is your caching and your queuing layers. Okay. Now, traditionally, we'd be talking application directly to the database a lot of the time. When I say application, that could be the web service layer talking directly to the database, or the executables talking directly to the database, thin client, fat client, whatever you want to call it. Okay. Having these queuing and caching layers can make life a lot easier, and we'll discuss them further down the line. So we'll start off by looking down here in the data platform there, and then we'll start thinking about, okay, well, how can we leverage these to make life easier here? And then we've got the layer above that we're typically going to be interacting with. These will be your web apps, these will be your web services, could be your power apps, anything like that that's actually going to be dealing with the inbound, outbound data. Okay, that's where we're doing the content generation will happen. Okay. So those are the three main areas that we have. Now, thinking about this, is anyone here currently using caching and queuing and such like in their architectures on a regular basis? Okay. Hopefully I will convince you to change that mindset by the end of this session. Okay? I hope. It's my objective. So, like I say, when we start thinking about the data store itself, the main areas we're looking at, we look at our data types that are available to us. Okay, we think about, can we use in-memory OLTP, the hackathon engine that was introduced with 14? We're using SQL Server 14? No, we can't really use it. You're using it in 14?
16.
Yeah, 16. 16 it becomes usable. 14 was, if you B-win, it's great. If you're not, forget about it. 2016's made it a lot more usable. There's a lot more data types in there. There's been a number of improvements in and around the way that it interacts with writing and reading the data from disk. Even though it's a memory-based system, if it's going to be persisted, it's got to write that data down. So, again, we've got some design patterns that we can potentially look at in and around them. Partitioning. Who's using partitioning in one form or another? Of course you are, you bet. No, I'm intimidated, I've got my hand in the back. So, there's a couple of different forms we're going to look at there. Sharding as well, which is interesting. It's, so is that about
what is sharding?
Sharding is essentially taking one database and turning it into many, and essentially, this is a very high level view. You have one master that essentially tells you, it's a map of where all the items are within the shards you've got. So your system will build a master and say, actually, I need to go get my data from here. You essentially build a mapping mechanism. It can be very good. It is, in my experience, quite complex. So if you don't get it right, it can go horribly wrong. But when it works right, it can be sweet. Really, really nice. And then from one of the configurations, about isolation levels, one of the most basic things we can look at to try and either improve the concurrency situation or diminish it, depending on what we need to do. Okay. Up this layer, this is where things like queues, worker threads, processing, intermediate layer, that's going to do some of the working, messaging, caching, that type of thing. Making the process asynchronous where we need to or can. And then the app delivery tier, web services, things like IoT hubs, event hubs, app services, web services. Is anyone here using the Azure services in one form or another? Being developers? Okay. Well worth having a look at now as well. And with Azure Stack coming down the line, building hybrid environments is starting to get a bit more viable to leveraging that processing power that's available to us. Like I said, whilst I did work with Microsoft for a period of time, I was sceptical about the adoption rates of Azure initially. But if you can get around some of the data sovereignty issues that may exist, then it is a very, very good platform for building very large-scale systems. Okay. So, we're going to start off down here, as I said. And we're going to start with one of the more basic elements of it, which is just simply around making sure you're using the right isolation level. Okay. So, serializable is where we'll start, which is the most restrictive of the options that are available to us. So, it's not great, okay? Essentially what it's looking to do is logically organize things in such a way that the transactions appear as if they're logically following one another. You can still run them in parallel in the engine itself, but the interaction between them, nope, not going to do that. Okay, main artifact, it prevents dirty reads from happening. Okay, so it means you're not going to be going in, you're not going to use no lock or anything like that, which we'll talk about later. But essentially, it's going to prevent you from seeing data that's in flight. Okay, also prevents phantom reads, because when most of the time, in my experience, although there are occasions where essentially it won't. What it does is it goes in when you read the data, it takes the locks, holds the locks. Until that transaction ends, basically. So you're not able to insert anything into those ranges. Okay, so this is typically taking range locks. So it's going to prevent you getting some data inserted again. So when you do that same query again, if you have to within the transaction scope, you're not going to get these extra rows showing up, phantom reads. Okay, so it protects us from that. Does cause a lot of locking though. Okay, can result in elevated numbers of deadlocks as well, depending on the way that you're actually looking at utilizing the query structures. Okay, so if you're going in and you've sort of got a query sort of design pattern where you're saying, okay, well, I need to go and check if this row exists, and if this row exists, I need to get the ID value, and then I'm going to take it down here, I'm going to either update it or I'm going to do something to it. With a design pattern like that, Running things like serializable and you've got a large number of queries coming in, that's going to cause you some pain. Okay? Know that from experience. Okay? Coming back to the solutions we build, we've got environments where we're monitoring thousands of servers, pulling it all back in through many monitoring services, large amount of contention in certain spaces. We've got to be very careful of this. Our code base has evolved over 10 years, and what worked 10 years ago, the volumes we're dealing with, didn't work now. So we fix it, because we can. So yeah, serializable. If you're running any of your databases in serializable, seriously go and have a look at them. Okay? Do you need to run all of your transactions at that level? If not, if you're using stored procedures or what have you, look at setting it at the session level if you have to. Okay? So just bear that in mind. You don't have to run the whole database and your entire workload at this isolation level. You can run elements thereof. Okay? Break it down. I do a lot of talks about security. One of the key things I say about security is thinking about scope. Same thing applies when we're starting to develop systems here. Think about the scope of the operation that you're performing. If it is only very, very small, and you need to protect it, only a small portion of it, then look at setting it in stored procedures, setting it at session level, that type of thing. Makes life a little bit easier. Because elsewhere, yeah, you might be able to use read committed, you might be able to use read uncommitted, anything like that. Okay, so there are options. Just understand the overall workload, which bits need to do what. Okay, so if you run a whole database in serializable, go and have a look and say, do I need to run that? If not, figure out which bits you don't. Then we come down to repeatable read, which is an interesting one. It's a little bit less restrictive on the locking side of things. It's essentially going to be locking the key locks. So when it reads the data, locks the data, but it doesn't prevent phantom reads. It doesn't prevent data being inserted in between records you may have read already. If anything happens that it needs to modify those pages that have been read, then yeah, that can have an issue, and that will cause elevated blocking. Your queries will be unhappy, is probably the best way to put it. But if you run the same query again in transaction, so if you run the query, someone inserts some data within that range, so you've got a where clause that says, show me everything for March, and someone inserts some extra rows for March, the second time you run it, if the key values are in there, but they weren't selected before, they may appear then, subsequently. So just be careful of that. Does prevent dirty reads, does cause locking and unlocking, which we talked about earlier. So same sort of artifacts, but it's a little bit less restrictive on the big scale. Read committed, this is our default in SQL Server. You know, I'll say SQL Server. Anyone here using Azure SQL Database? One person. No one really wants to admit to it yet. Don't worry. I don't like using it either. Big difference between SQL Server on premises and that engine and Azure SQL Database. Azure SQL Database uses read-committed snapshot isolation by default. Okay. So if you do end up transitioning from on-premises to Azure SQL Database, be aware that you need to go and double-check your code, because there are certain code constructs that mean you can see different behavior between the two engines for the same workloads. Kendra Little has got a really interesting couple of blog posts around it, so I'd say go and have a look at those. The links are going to be in the notes section on the slide deck, so you'll have that information as well. But coming back to read committed, it's our default one. It's middle of the road, prevents dirty reads, so not going in reading data. Still has all the same issues around the repeatable read side of things, that you can still have data reinserted. Essentially, it's locking it and releasing it as it goes at a very high level. Does cause blocking whilst it's in there, okay, doing the work that it needs to do. So, not too much to say about this. You probably see the vast majority of the databases running this. You just go and create database straight off the bat. You're probably running with read committed. Okay. Uncommitted, aka no lock. Okay. Probably one of the least restrictive. Although, who here is using no lock in their code? Come on, everybody put your hand up. You've all got it lurking somewhere. No lock lies. While it may not take the shared locks and such like when it does the reads, it will stick a schema stability lock on the objects. Okay? So, it lies, which is not fun. It's it's going to cause problems if you're doing anything like online index rebuilds, things like that. I have also worked on a system once where there was a month-end processing system, and what we've done is we had a development team. We did a lot of embedded stuff as well. One of our embedded developers came across to write SQL and brought that mindset of, I'll take this data from a table, I'll put it in a temporary table, I'll then move it to another temporary table, I'll take this data and I'll put that in there and I'll move it to another temporary table, and so on and so forth. So that was a 7,000 line store procedure. Lots of moving around between tables. Now, with the amount of no-lock that was going on there, because it took 9 hours to run, okay, well, we want to avoid not being able to insert anything during this process and what have you. No-lock was liberally sprinkled around, but some of the queries were running so long that data movement was taking place, and the process would fail and error out. Okay, so just be aware of that. If you've got some very long-running queries, you're using no-lock, you're doing a lot of this type of thing, they can fail because if you're manipulating that data in the background, those changes themselves are going to cause problems. So I would really look to try and shy away from this one. Like I say, you can go in, it's working. It's not going to typically prevent most of your workload from interacting with that table and those records. But just be mindful that it's going to cause pain. Also, if you're writing any queries that use no-lock, or the session is going to be running in read-only, if the numbers and the data that is being returned into whatever, reports, applications, anything like that, if the person then taking that data and presenting it to someone, if their job is on the line, if those numbers are wrong, this is not the option for you. Okay? Can improve concurrency, can lose people their jobs when they give the wrong financial results. Okay? Just be mindful. Then we're going to come up to snapshot, recommitted snapshot. These are really sort of some of the ones that will give you the most concurrency. Everything goes in there and works, but what it's doing is creating and using versions in the background. Okay? Very, very sort of similar to the technology that the in-memory engine is built on in regards to row versioning. Okay? Difference is here, this is going to be stored in tempdb. So, if you want to look at using these ones, yes, it can improve the concurrency. Just turn snapshot isolation on. Off we go. Snapshot isolation, okay, is scoped to the transaction level. Recommitted snapshot isolation is scoped to the statement level. Okay, so just bear that in mind. If you are going to say, okay, we'll go to using snapshot isolation. First of all, make sure your tempdb is scaled up properly. Okay, based around the amount of workload that you're going to be having. If you've got a lot of data change going on, what you need to understand is, okay, have I got any long-running queries? Because if you've got long-running queries, all that data change is potentially going to cause a large number of versions in tempdb. Tempdb utilization is going to go up, you're going to see more I/O, okay? Potentially, depending on how much data is getting put in and out of the version store, you're going to start looking at potentially GAM contention, SGAM, PFS page contention, things like that. So we're going to start needing to look at multiple files over and above what would normally be there for our standard workload. So by turning this feature on, yes, we gain higher concurrency, but we need to think about the overall performance and the impact it's going to have on the tempdb database itself. Okay. Likewise, if you're using RCSI, there are certain code constructs where you can get inconsistent results in the data. As I said, Kendra Litter's got some very, very good blog posts on that. I'd recommend that as reading material if you're going to start considering this. If you're using Azure SQL Database or planning to go to Azure SQL Database, this is going to be on by default. You can change that. So just take that one into consideration. But
yes. You can change it in SQL in Azure database.
Yes.
Yeah.
You can or you can't.
You can. You can. So you
can.
Yes.
Yeah.
You can change. Basically, you can change the isolation modes that are being used for the transaction levels up there.
But you can turn off recommitted snapshot isolation. It works.
Yeah. You can turn it off. I know it works as well because one of our competitors has said, look, you can do deadlocks and blocking in Azure SQL Database, but not unless you go and hobble the database configuration. Try not to be bitchy. Why would you do this? So, those are isolation levels. Those are the ones that we can get away with minimal change control, and we can vary them by workload, by procedure, by session, all that sort of stuff. So again, interacting and understanding the system approach, what's my whole workload, okay, which pieces of the workload do I need to work at what other level? So, now we move on to the data model itself. Now, a few years ago, a guy called Thomas Kaiser did some really, really good work in and around integers versus GUIDs for your clustering key to deal with really high inbound systems. Okay, this was an edge case, really. Unless you were working with the CAT team, you were or you had not great I/O subsystems, you were probably not going to come up against the contention issue where you've got a leading, basically you've got an ascending integer, you're basically going to hotspot on the leading page where you're allocating data all the time. You've got hundreds or thousands of threads coming in. If you're allocating that, it's going to get very hot because you need to take the lock to update all the appropriate things, and then you start page splitting, and that will go further up the chain. We'll discuss that in a moment. So there's a couple of ways we can look at doing this. One, we can switch over to using GUID instead of an integer. And as we all know, GUIDs are terrible. Sometimes. Sometimes they're useful. Sometimes they're very, very useful. This being case in point. Other options we have are based in and around partitioning. So we've got hash partitioning, partition views, and then we just got the traditional table partitioning. Now, table partitioning, I think, came down into standard edition of 2016 SP1.
It is.
It is.
Yes,
Yeah, sorry. So they keep changing the features for things now, which they never used to do. So Service Pack 1, partitioning is standard. Prior to Service Pack 1 in 2016, no partitioning. So, but you get loads of really good stuff in 2016 SP1. Hekaton, column store, partitioning, compression. Basically a huge pile of the enterprise-only features are now standard. They've got some limitations around sizes, but the cost is going to be a lot less to get a lot of that capability you may want to start off with and then scale later on. So we'll start discussing some of these. Specifically, we're going to talk about GUIDs, we're going to talk about hash partitioning, and a little bit about partition views as well. Table partitioning is an interesting one for concurrency. I find that it can aid more when you're dealing with reads from a performance perspective than necessarily when you're inserting data. Now, interesting story around that. I'm going for a slight tangent. I worked with a customer at a previous employer. I went in to do a health check on their system, and they had basically an OLTP platform with no clustered indexes. It was just heap after heap after heap, 4 terabytes worth of it, with a whole pile of partition non-clustered indexes on top of it, because they were under the misguided thought and notion that having these non-clustered indexes were going to improve their performance when it came to inserts, because they'll be inserting here and it's all going to concentrate the inserts based around that. If you're inserting into a heap anyway, you can get around that. You can do parallel inserts, so not necessarily there. So go and have a look at it. Understand the technology first. There are other less complex ways of doing it. Okay, unless we will start looking at things like hash. So GUID versus integer. As I said, if we're doing constant inserts, we are going to get down onto this page. So we're going from 1 to whatever int, big int. We're always adding the next value on, which always means we're going to be pushing that data into here. Okay. So that one gets hot, that one gets full. We allocate another one, and then we move the problem. Move it up the page. Okay. Back here, twiddling our thumbs. We might be doing a little bit of read here, read. But we're not doing much in the way of inserts. Well, sorry, we're not doing much in the way of updates. Whilst we are doing a lot of inserts. Okay, so we're not coming back here and locking everything. So, okay, well, if we're bottlenecking on this, first thing to do, improve the storage as best you can. Fusion I/O cards, some form of flash storage, NVMe, pure arrays, that type of thing. Okay, but then you're still going to end up potentially looking at hotspotting, because you just can't get anything into that page. You start looking at latch contention. That's when it moves up to memory. When it gets up to the memory level, that's when you're sort of all bets are off. We need to look at something else. So like I said, this is really sort of having a look at and saying, okay, this is going to be edge case. I saw a lot of people took Thomas's information. It was great information, but then they started building it into their 2 or 3 gig applications with a couple of users. GUIDs, scalability. Yeah, it's like, yeah, you're not pulling in 10,000 sensors from a manufacturing plant every second or that type of thing. Okay, you're not dealing with the volumes of data that necessitates this. But when you are, switching over to GUIDs means that we're randomly inserting into the structure. It can make life a lot easier. Okay? Basically, it will distribute the latch requirements that we have, spread it across the entire data structure. Yes, it will cause fragmentation in your indexes. Yes, it will cause page splits. Page splits down here, not horrifically painful. Page splits up in these levels, yeah, they can be very painful because there's a lot of data movement and a lot of log that's created. So, if you have got very high throughput systems and you want to start looking at this, the considerations you need to take into account, okay, what's my transaction log throughput? How big is my transaction log going to be? Okay, those are going to be the big ones. That's going to be, you're basically going to take the bottleneck and move it from one place to another. That's what performance tuning is. Disagree? Oh. I'm going to have this piece of pain, I'll make that piece of pain go away, and pain is going to materialize somewhere else. Okay? Can be very useful. Okay? There's a number of things you can simulate. So, who here's used OStress at all? OStress is part of the RML utility suite, which is a free download from Microsoft. You go and Google it, Bing it, whatever, search engine of choice. There's a little tool in there called OStress. Essentially, it's a command line tool. You say, right, run this query 100 times on 1,000 threads. Bam! Off it goes. So you want to punish a system and test for things like that. You know that this is going to be indicative of my workload. I'm going to run this procedure 10,000 times a second. We just go and run the procedure and hammer it as hard as we can. So, in the reality is you're going to experience issues elsewhere first. You're going to experience issues on log contention, you're going to experience I/O issues, that type of thing, before you're going to get up to there. Potentially memory configurations. We're talking many cores, high tens of cores typically. Lots and lots of memory available. That's when we're going to start seeing this issue. So we're going to come up against a lot of this first. Storage throughput, transaction log throughput, CPU throughput. Okay. It is an edge case. When you do have that, this was one of the ways that we look to deal with it. However, as we'll see, there are some options that we're going to have. Okay. The new architectures that are available to us make life a little bit easier. Okay. Now, moving on to table partitioning. Has anyone got any questions about this before we move on, by the way? Okay. I haven't heard any snoring, so I'm guessing most of you still awake. Table partitioning. Okay. Essentially, it's all about buckets. You've got no partitions. Well, technically, you've always got one partition. Okay. You create a table. That's it. You look in sys.partitions. There's got to be one there. Okay. We have one bucket in which I'm going to put stuff. The options are we can hash partition. This is an interesting one. Anyone who's familiar with the in-memory technology knows you've got your hash indexes. And essentially, you take a column. You say, I'm going to hash on this column. I'm going to derive a value, and then I'm going to put it somewhere. Okay. Same fundamental principle when it comes to hash partitioning. And there's a couple of things we need to think about if we're going to go down that route. The other option, which is one that I like, is partition views. There are a number of reasons I like partition views, and we'll cover those when we get there. But we think about hash partitioning first. One bucket versus many buckets. If I have 100 people trying to put little bouncy balls into one bucket, I'm going to end up with little bouncy balls all over the room. If I give everyone their own bucket, hopefully their aims look reasonably good. No balls bouncing around the room, knocking a beer over, that type of thing. Everything goes into their own bucket. That's essentially what we're looking at. Now, we need to understand, okay, well, what's my workload? Comes back to the workload again. Are you looking to retrieve that data or just for sort of raw insert power? Okay? So rather than going with GUID, you say, we're going to stick with integers, but we're going to go with hash partitioning. Okay? And I'm just interested in data ingestion. I might read it once every now and then. Okay? Great. If you're going to be reading that data, then you need to take into account, okay, I'm going to really need to look at including the hash in my where clause so that I can go in and find it without having to scan the entire table. This can be very, very efficient, okay, if you get the design right. Now the data distribution itself, there's a couple of options. One, we can round robin it, or like I say, you can come in there and say, well, this particular value I want to hash to this and put it in that bucket. Now, if we're going to take that approach, that one lends itself slightly better to going and retrieving the data rather than just round robining it. Okay? So, when you think about it, here's my little round robin animation. That chump away in the background for a minute. But essentially, if we're just putting it into the next bucket, that becomes very difficult to go and seek. Okay? So if we are inserting it and then we want to retrieve that data, having a value that we can pass in, hash, allows us to essentially start using it as a predicate. But the problem with that comes with understanding, okay, what is my data distribution going to be based around this hash value? Okay. A, are you going to have hundreds of values? Do you want them to be unique in the buckets, or are you going to let them coexist? In which case you're going to send up hash collisions, and then you're going to be retrieving again more data than you want to, which is not great. If you've got a finite number of values that you know you're going to hash to, yes, it becomes an option. But then if you end up with one that say, you hashing by city, for example. In the UK, if I hash by London versus Aberdeen, London's 7.5 million people, Aberdeen is arse end of nowhere up north with tens of thousands. I'm going to end up with distribution of data that's going to cause me pain. Okay? So, as we say, there's a couple of different options there. Next one is just off we go, we'll randomly insert things. So, there's two different options. Does anyone think they may have candidate workloads for this type of stuff? Or you're here because you couldn't get into another session? The truth comes out. So, hash partitioning can be very, very useful. Essentially what you're doing is, there's a couple of ways of doing it. One, you build your own function, and you build that as part of your insert statement. Okay, here's a value, put it in this one. Okay, rather than, so you essentially, you've got 32 values, you pass in something, if it's text or what have you, and you make sure you come out with modulus 32 or whatever to give you that whichever bucket's going to go in on the hash value. Build your own function, do it. If you want to do the round robin, then you've got the option of either using something like a persistent computed column or something like that, where you've got a sequence operator. So you say number 1 to X, cycle it, cache a whole pile of them as well, just try to speed that up, and then that will just zip it around nice and quick. Okay, as quick as you can allocate them, then you'll be able to push them in. So there's a couple of options you have available there. My preferred option is Partition Views. Essentially, this is a number of tables with a view above it. There's a couple of options we have here when it comes to the inserts as well. One, we can insert through the view and let the view. So if you've got the insert, you've got the view built with the check constraints on the tables, so that you can essentially do. The engine knows what value should be in what table. Then it allows you to essentially say, okay, data goes into these through the view. There are some locking issues in and around that. Whilst it can be great for distributing the data, it can also cause a lot of pain because you're taking various different metadata locks. Goes against building in for concurrency. Now, one of my reasons I like this is because when your system, if you large amounts of data ingestion, typically means that, okay, we're going to retain a lot of data, that data is going to get large. Large tables, even if you partition them, the query optimizer has still got a global stats object that it's going to be dealing with, okay? Even with even with the partition stats that you have now, the optimizer doesn't use them effectively. With this, I end up with a number of smaller tables, which means the data distribution of them can be a little bit better. I've only got 200 steps in a stats histogram. This one's going to help me potentially get a lot better query plans rather than I've got thousands of different values. My query plan, my stats object is very lossy anyway because I'm compressing it down to 200 steps. This option can help get around that. Okay, as we scale that up, you're essentially breaking it down into 1/6 of the issue it could be. Now the other option for this is to actually insert the data directly into the underlying tables. Now, there's a couple of ways you can do that. One, number of procedures, you can build your application, so you build that into the app logic. My personal preference is dynamic SQL. Dynamically generated code, nice and simple, okay, rather than one big procedure that's got how many tables do I have, okay, well how many if statements and such like do I want to put in place. That gets messy, the optimizer starts getting its head squished, and it's like, oh, well, just have this crap plan. Okay, dynamic SQL can help you get better plans in this scenario. Okay, dynamic SQL, we've had it for years, drilled into us, dynamic SQL is terrible. No, it's not. Used in the wrong context, it is. Used from the correct context, in this sort of example, yes, it can be very, very useful. Makes life a lot easier. Okay. The reality of this, though, is when we start getting up to these systems again, making sure if you're going to use the partitioning schemes for it, whatever, that's when it can start getting very painful. Okay, what are we doing? We need to architect in, okay, am I building my own function so I can start going to seek this data, or am I just round robbing it and then I'll scan it all at a later date if I'm using a logging system or whatever. Okay. Not great. Understand data distribution, you need to do that ahead of time. That's a big problem. If anyone's actually planning on going to Azure SQL Data Warehouse, that's a big, massively parallel distributed system where you're hashing it and distributing the data on a hash normally, or round robining it. That again, that whole platform, if you get that wrong, reports all games are wrong. And as I said, statistics and index management overheads. Now, one of the advantages is you can switch out and rebuild individual partitions, which is really nice. But when you start doing hash partitions on very high insert mechanisms, your switch option goes away. Okay. There are ways that you can do it with 2014 and above by saying, okay, this switch operation I want to set as a low priority for a waiting task, so things will bypass it. The problem is if you say switch on 2012 or below, or even do an online index rebuild, when it comes to trying to take the schema log to switch the item in, what it does is, okay, well I can't do this, so I'm blocked as a schema mod lock, which means everything queues up behind that until the workload finishes. It can do the switch and then work will carry on. 2014, there are mechanisms where you can say wait at a low priority and let things go past and then do it if you can. Okay. So it's better suited to solving other problems, just very large databases, very large tables, that type of thing. Okay. Break them down. Okay. Any questions about any of the partitioning stuff we just rattled over quite quickly there? Okay. Don't know if that's a good thing. Hopefully it is. Hopefully I'm answering the questions we've got. Now, in-memory OLTP, you're using it with 2016. Are you able to tell me anything about the system that you're doing?
It was a cloud. It was standing on cloud base. And I have to update it to
no, that's fine. I know there's certain things you can't disclose. In-memory OLTP has a number of options available to us. Okay, this can be really useful. Has everyone here heard of or looked at the Hackathon or in-memory OLTP engine that was introduced with SQL Server 2014 and improved with 16? Just okay. For all developers in the room, and this is a personal opinion, okay? So this could go horribly wrong in that I would envisage that in 2, maybe 3 major version SQL releases, the default choice is going to be the in-memory engine because of the capabilities it has. It's down in standard edition. It's nearly got parity with the core engine. Okay. The advantage it has is it's not built around locking and blocking, locking and latching. Okay. It's built around versioning from the very get-go. Okay. What that means is it's designed. Now the big one here is the key is in the name. OLTP. Small, short, sharp transactions. Okay. The reason being is it's what's termed an optimistic concurrency model that it uses. So it always assumes that everything that it depends on is going to complete successfully. What that means is that when you're doing lots of inserts, anything you're referencing, it's building up this dependency chain with other aspects of the workload, saying, I'm depending on this and I believe he's going to complete successfully. If that breaks, then everything that relies on that, the full chain, will also break. Okay? So if you've got long-running in-memory OLTP transactions, that can cause you more pain, okay? Because you start ending up with big dependency chains, and as soon as you start referencing data between those transactions where there's potential conflicts, that's when it breaks and falls over. So just be mindful of that. So with that in mind, there's a couple of patterns we can look at. Shock absorber is a very interesting one when it comes to applications. Anyone here who is doing ETL on bulk data loads, this is not covered really here in this one, kind of in the next total use perspective. But essentially, you've got durable and non-durable. Okay, durable still logs the transaction logs. So you need to make sure your transaction log is still very efficient, but you don't have the locking and latching into the data write perspective. However, non-durable doesn't do any logging, which if you're going to do bulk data loads and use it as a staging area, so pile this into a staging table and then I'm going to do some work on it. Non-durable tables. Server restarts, well I've got to reload my batch anyway. Saves you having to clear the table out. Service bounces, clean the table, off we go again. Not long. It is blisteringly fast. Okay? You want to do very, very large inputs very, very quickly. In-memory OLTP for your ETL staging tables can be very, very useful. Okay? Just bear that. And so move whole tables up. Now, the shock absorber. Essentially, oh man, I want to improve that before we do that one. We have an in-memory table. We've also got disk-based tables. And essentially what we do is we write here into the memory table. That's our primary focus. That's where we're dealing with the locking and latching that we want to try and avoid. Avoid. Teeth back in. Not enough beer last night, I don't think. What it does mean though is, we've got one process that writes. We need to have a worker process here, transferring this data down. This is not automatic. This essentially is something you have to write. There's no in-memory service broker queues yet, so there's no activated stored procedures. Essentially, you have to have an application that will spawn off a thread and say, actually, I want to transfer data from the memory table to here. So whilst here you may have thousands of items writing into it, that's where you're looking at the concurrency. This bit here. This is what I'm interested in. Okay? I've got thousands of items writing into the memory table, not dealing with the locking and latching issues that I have. I then maybe have 10 worker processes streaming data down to the disk-based table. So essentially it's a funnel mechanism. Big wide funnel at the top, that's where my concurrency pane is. That's where I need the most concurrency. In reality, I've got it here, it's in a durable table, putting it down, putting it on the disk. That's where we're going to go from there. You can then logically extend that out, and we can say, okay, I've got low, medium, and high priorities. Multiple different worker threads on each one. Writing data in. Some of the high priority is going to get there quicker than the low priority stuff. Okay? This is akin to almost like the sort of queuing mechanisms we do elsewhere in the applications, up in the application tier itself. Okay? So what we're doing is actually just pushing it down into the engine. Now that it's available in standard edition, it does become a little bit more viable than whereas before we had to have enterprise. Okay? That's my active picture. Okay? But like I say, you need to write code that will spawn off and manage those worker processes. Okay? Where are you going to use this? Make sure you've got plenty of memory. When I worked for Microsoft, we had a support ticket come in. It's not working. Everything breaks. Okay, well what? Well, I've got 32 gigs around on my server. Okay, well how big's your table? 60 gig. Which bit of in-memory do you not get? If it's not able to fit in memory and become entirely memory resident, it's not going to work. Okay? Whilst the data is persistent on disk, it gets streamed out of disk into memory, and then everything comes online. Okay? So you need to make sure. Now it's not just a simple case if I had 60 gig on my table, I need 60 gigs of RAM. Okay? The reason being is, as you create all these versions in the background, you're creating old versions. You update it, it doesn't update a record, it creates a new one and marks the old one basically the garbage collection. So you've got a garbage collection process that's going through there. So there's always going to be a memory overhead associated with how active your workload is. So the higher you get on the scalability for your workload, the more overhead memory you're going to need to take into account. Okay. Similar sort of thing on disk because it's writing down data in Delta files. So where you're saying, okay, I've got a very active workload, you're actually going to maybe take up your 30 gig table, you may take 45 gig, 50 gigs of disk space, whilst it writes that data down into the data files, writes it down to the Delta files, which are essentially a bitmap filter when you load the data out. But then it will consolidate things as it goes through as well. Okay? So there's, again, a disk-based overhead as well associated with this technology. Don't use it with 2014, don't bother. 2016, yeah, still workload dependent. Can you get around some of the limitations that may exist there? Azure SQL database, if you're made of money, yes. You start talking about, you need to get up into the big premium tier for this, where you're talking thousands of pounds a month in the UK. I think there's one that's up to about 16,000 a month, and the top end performed with the P scale. Okay? Adds a lot of complexity. Like I say, you need to write a lot of the code yourself around handling those worker threads that are moving things from memory to disk. Okay. So, That's what we can do with the database platform itself. SQL Server, Azure SQL Database, things like that. Once we've looked at some of the new technologies, doing everything in the database tier is, it's not as scalable as we can get by really scaling out the application. Okay? We can get data and materialize it there. If you can make the process of putting the data into the Datastore asynchronous, so if it's a case of, okay, if I write it and I know it's durable now, my application, and give someone their order number back, but it doesn't need to hit my database for 20, 30 seconds, that's fine. We can make this process asynchronous. If it's a case of I write it and then I need to read it immediately, yeah. Then we need to start looking at potentially hybrid environments. And when I say hybrid environments, I'm talking about different access mechanisms. So, we start thinking about caching, queuing, okay? So, here we go. Essentially, we have a very simple application sort of environment here where I've got either a web client or I've got a fat client that talks to an application server that then talks to my data store. Essentially, we're funneling things in here. Now, I'm going to go away from the whole, we've got a Windows Forms-based app that talks to the database, and we've got 10,000 users, because that's just, ouch, that hurts, okay? We'll try to avoid that. What we're going to do, it's about building that funnel, okay? We handle the very high requirements we've got for the numbers of users, and we funnel them down into sort of smaller channels, okay? Those smaller channels essentially need to act as buffers. So I've got 10,000 users talking to maybe 100 app servers, maybe less, okay? The app servers will start interacting with things, taking those, receiving them, and saying, okay, I'm going to pass this on to a queue, okay? Then, so if I don't need to write directly to the database for everything, then, okay, I'll stick it into a queue. So, again, if I've got many application servers, I may then have it all going into one queue. So the Azure Service Bus, Azure storage queues, things like that. There's a lot of scalability in there, and it's just a case of, okay, 2 lines of PowerShell, and I've configured a system that is very highly scalable. Rather than having to write hundreds of lines of code, I've created an application environment where my app, my web service, or whatever can just put it onto the service bus queue, and depending on the number of partitions I create or what have you within the queuing mechanism, Azure just handles it. I don't have to worry about scaling out hundreds of servers, I don't have to scale up hundreds of services, anything like that. It just gets handled for me. Then I just have a worker process that's pulling that down. So thinking about what we talked about with the shock absorber process for in-memory OLTP, we're essentially moving that out of the database now and building it up into queuing. There's also things like RabbitMQ, MSMQ and such like as well. If you want to build it into your on-premises applications, you can go down that side. I'd say shy away from MSMQ because it's a bit crap. RabbitMQ is one of my preferred queuing mechanisms. Also runs very well on Linux, so licensing costs go down. So when you think about some of the queuing options, as I said, on-premises, things like Rabbit and MSMQ. If we start thinking about Azure itself, we've got Service Bus, storage queues. They're basically virtually the same thing, just the message size is going to be different. Okay? Service Bus can handle larger messages than storage queues. Essentially, you're just writing it in. BizTalk services. BizTalk on-premises was an absolute pig-in nightmare. BizTalk services up in Azure takes a lot of that pain away. The pain really was coordinating the backups across a number of databases so that when you bring them all online together, they're consistent. Event hubs and IoT hubs, very, very useful at high-rate data ingestion. Okay? IoT hub, name gives it away there, sensors, hundreds, thousands of devices talking into one location. Okay? You can build hubs around the globe if you need to. Okay? We're starting to build out a solution now where we're using actually event hubs to gather information. Okay? We don't need to build huge quantities of stuff. We just say, well, there's my endpoint at that position, that part of the globe. That part, then people in a certain geographic area, boom, there we go, data in there, nice and happy, done. Azure Cosmos DB. Did anyone watch the Build keynote, the Build conference from Microsoft the other day? Yeah. Okay, it's recorded, it's on Channel 9. Go and check it out because they announced some really cool stuff. Cosmos DB was Document DB, but now is essentially part of the global Azure platform where it's a JSON and graph and key value pair store that you can say, well, just put instances of data everywhere around the world. You actually configure that now. You don't need to build the whole architecture yourself. It's very akin to the sharding mechanism we spoke of earlier. So it's well worth having a look at. Okay, you can do an awful lot with it very, very quickly. We've got caching as well, so this is where we start building it. So there's always going to be an element where we have to talk directly to the database itself via the app tier. But anything, the amount of this traffic that we can minimize, the better. That will give us more concurrency in the overall system. We're writing data in here through the queues, I'm just loading it in. So as this scales up and scales down, the queue just goes, oh, well, I've got more on me today than I had yesterday. And the worker thread's, okay, well, maybe I need to spawn another worker thread. But you're dealing with tens rather than hundreds, potentially thousands. The cache. The caching mechanism here is essentially, okay, what sort of static, very low rate of change or very non-volatile data do I have that is constantly used in my application systems? That's the type of thing you want to cache. So, coming back to the database engine, yes, you could use non-durable tables. Database comes online. You've got a startup process that says, okay, we'll load this information into a non-durable table. It's memory optimized. I can get to it very quickly. Best bet, actually move it out to the app tier. Okay. There used to be App Fabric for Windows, but Microsoft has deprecated that in favour of Redis cache is really one of the de facto standards out there now. Very, very efficient mechanisms. The hosted one's a lot more up in Azure. It's very easy to use compared to building out the environment on premises or in VMs. The service makes life a lot easier. Content delivery networks. Now, these are pretty universal. Well, I'm mentioning Azure, which is what I'm familiar with as a cloud platform. This is also available for AWS and things like that. Content delivery network, again, is very, very useful for handling static data. Okay. If you've got something that's serialized, for example, you've got a PDF, you've got a video file, that type of thing, you basically put it to distribution points, and then your application just calls a web service, and it never goes near your database. You basically say, much the same way you've got a DNS record, you've got a time to live. How long is that data valid for before it needs to be refreshed? You define that here. Okay. The content delivery network basically pushes that close to where your end users are, which means you're not going back and hammering the database, potentially for large volumes of data. Troy Hunt. Has anyone heard of Troy Hunt? Again, another guy, he's a security researcher based out of Australia. Really, really good guy. He's got a database, haveibeenpawned.com, so put your email address in there. If it's involved in a breach, you get a notification, because he goes and collects all of them and says your details are compromised. But there was a very big issue the other week, and he just moved his websites over to using CDNs, and the delivery of a large number of images, basically through the content delivery network, offloaded the amount of actual access he was having to do back into other areas. He's got a graph that shows just how much that spike was handled by the content delivery network mechanism. So it's a good illustration of when it's appropriate to use and what we can do. And Cosmos DB, it's not just used for queuing things in, it can also be used for caching things as well. It's schema on read, JSON based storage. Very, very good. Then we come up into the app tier, and this is where it all sort of sums up. My preferred architecture is things like SOA. Microservices is now the latest buzzword for it, essentially. Break it down into lots of small components that are interchangeable, loosely coupled environment. Okay, we're breaking it down. We've got queues, we've got cache, we've got various different technologies we have available to us. We break it down into little components. It becomes very easy for us to swap them out, change them as we need to. It's a very rapidly changing environment. Okay, anyone here who works on a small startup, potentially something goes viral, you end up with 2 million users inside of the first 3 months when you'd anticipated maybe 20,000. This type of architecture where it's highly scalable makes life a lot easier rather than having to go back in and refactor your database architecture. The database, once you've written it, becomes very difficult to change those data structures. Try to break out a table. Okay. The environment our solution, we had a recent change where we had to break a couple of tables in half. Which is great in our dev system, but we've got customers monitoring 200-300 servers, and we've got to do a whole pile of things of flipping them around as part of the install and the upgrade. Not easy to handle when we deal with an ISV. But moving on to this type of architecture, I've got the Datastore. There's one of them. Nice and easy, one version of truth, change that, not a problem. But it's very difficult when you think of everything further up that's depending on that. Okay. So in summary, the data platform environment is changing. Whereas before we used to do everything in SQL Server. Now's the time to start looking at moving to the other technologies that are available to us there and things that are further up the stack. Okay. Modular, loosely coupled, SOA type architectures have an awful lot going for them. Please go and explore those options. When we're building data platform is more than the database. It is everything. It's the system, the platform on which we're providing a service. It's about that service delivery. Okay. And with that, if anyone has any queries or questions, it's time now, so I'll be here for the rest of the day and tomorrow. Business cards at front if you want to get in touch with me. Big thanks to all our sponsors again, and thank you very much to you for coming.